Welcome to this overview of xlSlim. xlSlim is the easiest way to call Python functions from Excel without making any code changes or installing any extra packages. Python lists, dictionaries, objects, Numpy arrays, and Pandas data frames are all supported and cached automatically. You can call existing VBA functions and other Excel add-in functions from Python. You don't even need Python installed, as Python 3.10 is included. Let's start by looking at this simple Python module that defines three functions to calculate the area of various shapes. As you can see, there is nothing special about them. xlSlim makes it very easy to call these functions from Excel. First, we copy the module location to the clipboard. Then we open xlSlim by double-clicking on the desktop shortcut. In Excel, we use the register Py module function to register the module and make the functions available to Excel. As you can see, the functions are registered with identical names and signatures. Notice how the types and docstrings have been detected. We call the function. Behind the scenes, this is calling into Python and calculating the area of the circle. xlSlim makes it possible to call any VBA function or Excel add-in function from your Python code. This is made possible by this magic global function xlSlim UDF-func. If we have a VBA function like this, area circle, which calculates the area of a circle, we can call it, of course, in Excel, as you would expect. However, using xlSlim, you can call this function from Python as well. So if we look at this Python code, you will see the function UDF circle area is using the xlSlim UDF-func to call the VBA area circle function. And as I said, you can call any Excel add-in from Python using this magic function. So any of your existing add-ins, analytics libraries, and so on. So we copy the location to the clipboard as usual. And then in Excel we register the function. And now we can call the UDF circle area function, which will make a call to Python, which calls back into VBA. xlSlim caches Python dictionaries and objects automatically. What this means in practice is Python objects and dictionaries are never displayed in Excel cells. Instead, they are represented by cache handles. xlSlim takes care of translating these cache handles into the real objects when calling Python functions that expect a dictionary or a Python object. Let's see how this works in practice. We'll start by looking at this passing dicts Python module. Notice the three functions: create person dict, describe, and average age. Create person dict creates a little Python dictionary which contains the details of a person, their first name, last name, and age. The describe function will return a string describing that person. Lastly, the average age function takes in three dictionaries representing three people, and then returns the average age of those three people. If we run this module, it runs as expected. Let's copy the module location to the clipboard. Now let's look at this passing objects module. As you can see, it defines a person class. The person class contains the details of a person, their first name, last name and age, very similar to the dictionary we were just looking at. The module also defines 3 functions: create person, describe and average age. Notice how the describe and average age functions have exactly the same names as the passing dicts module. Also notice how the average age function accepts a list of people. This is slightly different to the average age function in the passing dicts module. If we run this module, you'll see it runs as expected. Let's copy the location into our clipboard as well. Let's move over to Excel, where I've pre-populated some people details. We start by registering the Python module as usual. Then we call create person dict, passing in first name, last name and age. Notice how a cache handle is returned. We copy that down and we get 3 cache handles. Next we call the describe function, passing in a cache handle. Notice how behind the scenes xlSlim is translating that cache handle to the real Python dictionary before calling the Python function. Finally we call the average age function, passing in 3 cache handles this time. And the average age is calculated as expected. Next, let's look at the passing objects Python module. We begin by registering the Python module as usual. You may recall that some of the function names in passing objects and passing dicts were the same. Therefore, we use the optional module prefix argument for the first time. We register the functions with the prefix O_. This has the effect of registering the functions with a different name in xlSlim. Notice how the functions now have an O_ at the start, for example O_create person. We create a few people. Next we call the O_describe function, passing in a cache handle. Behind the scenes, xlSlim is translating that to a real Python object before passing it to the Python function. Then we call the O_average age function. Notice how this time we pass in a range of cache handles. Behind the scenes, xlSlim translates this range of cache handles to a list of Python objects, which is what the function expects. It can be really useful to view these Python objects on the Excel spreadsheet. There is a utility function in xlSlim called viewPyObject. This function can be used to view any Python object that has been cached. We start by looking at one of the Python dictionaries we created earlier. Notice how xlSlim automatically displays the keys in one column and the values in the other column. We can use the same viewPyObject function to view a Python class. And the results look very similar, even though one is a Python dictionary and one is a Python class. xlSlim comes in 2 versions, a free version and a premium version. All of the features we've covered so far are available in the free version. However, all of the really powerful, valuable features are only available in the premium version. The premium features require a premium license. The premium features are being able to use an existing Python environment, full support for Numpy, full support for Pandas, both Pandas series and Pandas data frames, and finally the ability to run Python in a background process, so not the main Excel process. We'll look at all these features in turn. By default, xlSlim uses a bundled version of Python 3.10. However, this bundled version only has the Python standard library included. Notably, it excludes popular packages such as Numpy and Pandas. If you need to use packages which are not in the standard library, you will need to use an external Python environment. xlSlim supports a standard default Python installation, Python virtual environments, and Conda environments. Let's look at how xlSlim can be used with a Conda environment. We start by opening the Conda command prompt. We type where Python to find out where our Python is installed. Copy the folder where Python is installed. Launch a fresh xlSlim instance. Now we register a Python module in Excel. I am registering a module with some Numpy functions. Therefore this module requires Numpy. I have Numpy in my external Conda environment. I pass the location of the Conda environment as the second argument to the register py module function. We can see the module has been registered as well as the Python environment has been initialized. If I re-register that module, you will see that the message is simpler. This is because the Python environment is only initialized once. If you need to change the environment, you will need to restart Excel. xlSlim understands Numpy arrays. Numpy arrays can be created directly from Excel ranges, or alternatively Numpy arrays can be created within Python functions. Once Numpy arrays are created, they are cached automatically by xlSlim. As usual, cache handles are translated to and from the real Numpy arrays when needed by Python functions. Let's look at some code. This is the Numpy module I registered earlier. As you can see, there are a number of functions. As usual, these are regular Python functions with nothing specific for xlSlim. All we have are nice type hints. We have a function to create a random array, a function to invert an array, a function to simply echo an array passed. We have a function to add a list of arrays, a function to multiply a list of arrays, and finally a function to add two arrays. Let's register that Numpy module in Excel. We use the register py module function as usual. Note that we are still using the Conda environment I initialized earlier. When xlSlim registers a function taking in a Numpy array as an argument, it creates three variations of that function within Excel. There is a version that accepts an array created from a range of cells. There is a version optimized for only numbers, and there is a version that will take in a cache handle. Let's see how that works in practice. We create two square arrays as an input. We pass those two ranges to the add two arrays function. Behind the scenes, xlSlim has created two Numpy arrays from those two Excel ranges and passed those Numpy arrays through to Python. Python has then added those two arrays together and returned the new Numpy array back to xlSlim. We can view this new Numpy array using the regular viewPyObject function, and we can see the code has worked as expected. Our Excel data in A2 to B5 only contains numbers. Therefore we can use the optimized version of the add two arrays. We can use the add two arrays num only. The optimized num-only versions are very beneficial if you are passing in large Excel ranges. We can view the result as usual using viewPyObject, and the results are identical as expected. Finally, let's pass in those two arrays as handles. So we pass in the cache handles from A6 and A9. Viewing the PyObject shows that they are added as expected. Let's clear that sheet and see how we can create a Numpy array within Python code. We call the createRandomArray function to create a random 3x3 array. We can view the array using the regular viewPyObject function. Let's invert that array. We can use the invert array from handle function, passing in the handle at A2. We can see the array has been inverted as expected. We could use the optimized num-only version of invert array num-only, passing in the Excel range. This will give the same results. Note that it is always more efficient to pass data using cache handles wherever possible. Let's look at xlSlim's support for Pandas. xlSlim supports Pandas series and data frames. They can both be created directly from Excel ranges or within Python functions. As usual, we'll start by looking at some code. Let's focus first on Pandas series. This module, series.py, has a range of functions that manipulate Pandas data frames and Pandas series. Let's first look at the createRandomDataSeries function, the describeDataSeries function, and the concat2DataSeries function. You'll see these functions all accept or return Pandas data series. We register the series.py module in Excel. We're still using the Conda environment I initialized earlier. Let's enter a Pandas series as a range of cells. Column A is our index, column B is the values. We call the describeDataSeries function, passing in the range A2 to B5. xlSlim will automatically treat the first column as the Pandas series index and the second column as the Pandas series values. We can view the Pandas series object as usual, and we can see that the function worked as expected. If we adjust an input, we can see the values flow through as expected. Just as with Numpy, xlSlim creates a optimized version of each Pandas series function. So there is a describeDS_numonly function, which we can use as our range A2 to B5 only contains numbers. Let's enter a second series. Column D has our index, column E has our values. We'll call the concat2ds_numonly function. That's the optimized version of the concat2ds function. Notice that we set ignore index to false, so our index is used as expected, and we can see that worked as expected. Let's look at the concat_ds function. The concat.ds function in Python is written to expect a list of pandas data series. Therefore, it expects a range of cache handles in Excel. We only have a single cache handle at the moment in this sheet, so we can use the utility function createRange. createRange will create a range from 2 copies of the cell A6. And we can see the pandas data series are concatenated as expected, and we have 16 rows as expected in our pandas data series. Let's look at concat2ds from handle. We can pass in the handles at A6 and A7. This creates a new data series with 24 rows. If we amend an input, the amendment flows through as expected. Okay, let's look at creating pandas series from Python functions. First, we clear our object caches using the utility function clearCaches. This is a helpful function to occasionally clear existing cache data. We'll use the createRandomDS function to create 2 random data series. We now have 2 handles to the data series. The handles are in A2 and A3. We can view the data behind A2. And we can call the concat.ds function, passing in the range A2 to A3. Behind the scenes, xlSlim transforms that range to a list of Python pandas data series. And it works as expected. Moving on from pandas series, we look at pandas data frames. First, we look at the Python code in the series.py module. Specifically look at the describeDF function and the createRandomDF function. DescribeDF uses the standard pandas describe function, and the createRandomDF function simply returns a random data frame. Back in Excel, we start by clearing the object caches again using the clearCaches function. Then we call the createRandomDF function to create some random data frames. Notice how I'm not passing in the first 2 arguments. xlSlim is quite capable of handling default arguments. We can view the data frame that was created. And we can pass in the handle to the describeDF from handle function. Let's look at how to create a pandas data frame from an Excel range. xlSlim will assume that your first row contains your column names and your first column contains your index. We call the describeDF function, passing in the range A2 to C6. Behind the scenes, xlSlim creates a data frame that's then passed to the describeDF Python function, and we can see it worked as expected. If we adjust an input in the cell, the change flows through as expected. The final premium feature we look at is running xlSlim's Python in a background process. This is not a feature most users will ever need. However, it is very useful for certain use cases, specifically if you have an Excel add-in and a Python package that end up referring to the same Windows DLL. If you need to have different versions of that Windows DLL, the only way to do this is to run Python in the background process. xlSlim lets you do this. There is an optional argument when you register a Python module. As you can see, the optional argument is use background process. If we set this to true, xlSlim behaves as before. The only difference is that now everything runs in a background process. We can see if we re-evaluate A7, the cache key is slightly different. This is because the data is now cached in that background process. Otherwise, you shouldn't notice any difference at all. And that concludes our overview of xlSlim. I hope you found it useful. Please do read the documentation and download the code examples from GitHub. All the code we've shown is available on GitHub, and the Excel spreadsheets have many tips and tricks in them. Thank you.